All right, let's open a new case file. Today, we're investigating a microscopic suspect responsible for some major crimes against public health. Our target? Streptococcus pneumoniae.
You know, in the world of microbiology, this pathogen has earned a pretty notorious alias. It goes by the capsulated sniper, a name that, you'll see, perfectly captures its stealth, its precision, and its deadly effectiveness.
So who exactly is this menace? What's its deal? What makes it so incredibly successful at what it does? Well, we're about to run a full background check, covering everything from its physical description to its method of attack.
Okay, let's kick off the official briefing. It's time to formally identify our target and really get a handle on the scale of its operations. So here's the official ID, Streptococcus pneumoniae. It's a gram-positive bacterium, and you usually find it hanging out in pairs. And listen, this is no small-time player. It's a global leader in causing pneumonia and a whole host of other severe invasive diseases. And just look at this rap sheet. The charges are extensive. We're talking about the #1 cause of community-acquired pneumonia, plus life-threatening meningitis and sepsis. It's also the usual suspect in less severe but super common infections like ear infections and sinusitis. You know, to catch a criminal, you have to know what they look like. So let's move on to the suspect's physical and biochemical profile to see how forensics can pin down its identity. Think of this as the suspect's mugshot. It usually shows up in pairs, with this really distinct pointed or lancet shape. But its most critical feature, the real giveaway, is that thick polysaccharide capsule. That's its signature cloak. In the lab, it leaves another clue, a kind of greenish haze on blood agar, which we call alpha hemolysis. And just like a real fingerprint, these biochemical tests give us a definitive ID. It's catalase negative, and, crucially, it's sensitive to a chemical called optochin. That's what separates it from its close relatives. It also dissolves in bile, another key trait that confirms we've got our guy. These are the tests that make the case absolutely airtight. So, where does the sniper like to hide out? Well, its main reservoir is the human nasopharynx. That's the upper part of your throat, right behind the nose. And get this, it can just lie low, totally dormant in a huge percentage of the healthy population, just waiting for an opportunity. It likes things cozy, thriving in environments with a little extra CO2 and right at our own body temperature, 37 degrees Celsius. Okay, so we know who it is and we know where it hangs out. Now let's look at its tactics. How does it go from being a quiet resident to an aggressive, full-blown invader? Let's break down the anatomy of its attack. Its MO follows a pretty clear pattern. First up, colonization. It uses these specialized proteins called adhesins to latch onto the lining of the throat. Then it deploys that all-important capsule, which acts like a shield to evade our immune system's first responders. And the final step is invasion. If it gets accidentally inhaled down into the lungs, the real assault begins. And this is the aftermath. When this bacterium invades the lungs, it triggers this massive inflammatory response. Fluid and immune cells just rush in, flooding an entire section or lobe of the lung until it basically becomes solid. This lobar consolidation is the classic evidence left at the crime scene, something you can actually see on an X-ray.
Of course, an attacker is only as good as its weapons. And this sniper? It is armed to the teeth. Let's take a look inside its arsenal of virulence factors. Its #1 weapon, without a doubt, is the polysaccharide capsule. And this thing isn't just some simple coating. It's a highly sophisticated anti-phagocytic shield. What that means is it literally prevents our immune cells from being able to grab onto and eat the bacterium. It is the single most important factor for its survival and its success. Yeah, the source material puts it perfectly. This capsule acts like ballistic armor. It doesn't just block physical attacks. It effectively hides the bacterium, preventing our immune system from even getting a clear line of sight to target it. But that armor is just for defense. For offense, it has weapons like pneumolysine. This is a powerful toxin that literally punches holes in our cells. It also paralyzes the tiny hairs or cilia that normally work to clear our airways, and it just throws our own immune system into chaotic overdrive. Right, so if the capsule is its armor, think of pneumolysine as a molecular fragmentation grenade. It doesn't just kill a few cells, it creates widespread chaos, destabilizing our defensive barriers and cranking up inflammation to cause even more collateral damage. And the weapons cache doesn't stop there.
Oh no, it has an enzyme called autolysin, which is like a self-destruct button that allows it to release even more toxins all at once. It's got a protease that specifically chops up our antibodies on mucosal surfaces, and it has hyaluronidase, which dissolves the glue between our cells, allowing it to invade even deeper into our tissues.
So, we've seen the suspect, we've seen its hideouts, and we've seen its weapons. Now it's time to bring it all together for the final verdict. Who is most at risk, and what's our overall assessment of this threat?
You know, this pathogen doesn't target everyone equally. This sniper has its preferred victims: the very young, whose immune systems are still developing, and the elderly, whose defenses are starting to wane, are at the absolute highest risk. And of course, anyone with a compromised immune system is a prime target. So why these groups? Well, it's because this sniper is an expert at exploiting weaknesses. It specifically targets individuals who have gaps in their defenses, whether that's weakened immunity in the airways, a spleen that can't properly filter the blood, or any other kind of compromised defense system. So here it is, the prosecutor's closing statement. Streptococcus pneumoniae is a highly efficient, encapsulated pathogen. Its specialty is rapid, targeted assault, made possible by that incredible capsule. It is a true master of stealth and devastation. But here's the final, and maybe the most challenging piece of the puzzle. That capsule, its main weapon, comes in over 90 different varieties, or serotypes. Think of these as different disguises, allowing the bacterium to constantly evade our vaccines and our immune memory. We develop protection against one disguise, and it just shows up wearing another. And that leaves us with this one critical question. With an enemy this adaptable, this well-armed, and with more than 90 disguises in its wardrobe, is this a villain we can ever truly put behind bars for good? That's the challenge that continues to face scientists and doctors all over the world.